Today we'll be doing the integral from 0 to infinity of the inverse tangent of x divided by 1 plus x squared dx. And to start off, we'll make the following observation that the derivative of the inverse tangent of x is 1 over 1 plus x squared. So we can rewrite our integral as integral from 0 to infinity of the inverse tangent of x times the derivative of the inverse tangent of x dx. And we'll let u equal tangent inverse of x, which means that du is 1 over 1 plus x squared dx. Which also means that dv is the derivative of the inverse tangent of x, which means that v equals the inverse tangent of x. So we have that j equals the inverse tangent of x squared from 0 to infinity minus integral from 0 to infinity of the inverse tangent of x divided by 1 plus x squared dx. So that means that j equals the inverse tangent of x squared from 0 to infinity minus j. So we have 2j is the limit as x goes to infinity of the inverse tangent of x squared minus 0 squared, but 0 squared is 0. So we have that 2j is the limit as x goes to infinity of the inverse tangent of x squared. So this means that 2j, as x approaches infinity, this limit will tend to pi over 2, but it's squared, so we have pi over 2 quantity squared. So 2j is equal to pi squared over 4, which implies that j is pi squared over 8. So in the end, we have that the integral from 0 to infinity of the inverse tangent of x divided by 1 plus x squared dx is equal to pi squared over 8. And this is the final result. Thank you very much for watching.